Hello everyone, my name is Mane Vishal Abhimanyu and I am from IIT Patna. Today I will be teaching one of the important concepts of calculus, that is limits. It is also very important for JEE Mains and advanced exam. So before going into the topic, let us first understand what is a limit with one example. Suppose you are watching a soccer game and unfortunately you have very poor connection that day. So due to this you missed what happened at 4. You get buffering. But even so, can you predict the ball's position at 4? Yes, it's easy, right? You just grab the neighboring instances, that is 359 and 401. And by using these two instances, you can easily predict that the position of ball at 4 must be somewhere in between, that is somewhere here. And it's correct also. So what you are doing exactly here, you are you don't know actually what happened at 4, but by using neighboring instances you are able to predict the position of ball at buffering period. Okay, and this is what we call limit in mathematics. That is, what is a limit? Limit is our best prediction of value of function at a point which we didn't observe. Suppose we have function defined on this domain and there is some point a. We don't have the value of function at point a. We may have, but assume that you don't have any value of function at this point. There may be multiple reasons. Maybe the function is not defined at a. But if you still observe its function's behavior near this point, so this prediction of behavior of function at this point that we didn't observe is called as limit. So another question may arise that why do we need limit basically? The reason for this concept is actually math has black hole scenarios. You may face many situations where you have to divide by 0, you have to go to infinity, and likewise. So in this type of situations, limit gives us estimate when we can't compute result directly. Okay, this is basically because not everything is defined in mathematics. Okay, there are many cases in mathematics that we can't even imagine. So anything that we can't define in mathematics are called as indeterminate form, and majorly there are 7 indeterminate forms in mathematics. First one is 0 by 0, infinity by infinity, 0 raised to 0, 1 raised to infinity, infinity minus infinity, 0 into infinity, and infinity raised to 0. In these cases, suppose 0 by 0, mathematics don't have in mathematics 0 by 0 does not mean anything. It's meaningless quantity. So likewise, all the 7 are meaningless quantities. They don't have any meaning in mathematics. So let us understand this need of limits through one example. Suppose you have function x square minus 1 upon x minus 1, and you have to determine the behavior of this function at point x is equals to 1. So if you directly substitute value of point inside the function, then you will get 1 square minus 1 upon 1 minus 1. That is 1 minus 1 upon 1 minus 1. 1 minus 1 is 0, so 0 by 0, which is indeterminate form as we discussed earlier. That means this function is meaningless at point 1. In other words, we can say the function don't give any output at point x is equals to 1. So here in such cases we have to use limits, and limits gives you a proper explanation or proper a prediction for the behavior of a function at 1. So how to use the limit in this case? We know we have problem at 1 only, right? This function gives 0 by 0 only for x is equals to 1. All the other points except 1 we don't have any problem actually. So problem is at x is equals to 1. Now recall the soccer game example. In that example we have predicted the position of ball by using neighboring instances, that is before buffering and after buffering. So likewise we are going to do here. We are going to analyze the behavior of function before point 1 and after point 1. And how we are going to do this? we are going to observe the point from, let's say, from 0. At x is equals to 0, x square minus 1 upon x minus 1 will give us 1. If you go more closer to 1, suppose at 0.5, we are getting value of function as 1.5. If you go more closer to 1, then for 0.9 we are getting 1.9. Similarly, if you go very close to 1, like for 0.99999, we are getting value of function as 1.99999, which is approximately equal to 2. Okay, so what we notice here, if we approach 1 from its left hand side, we are getting that value of function is also approaching towards 2. Now let us find the behavior of function if we approach 1 from right hand side. So if x is equals to 2, the value of function becomes 4 minus 1, that is 3 by 1, means 3. If we go more close to 1 from right hand side, suppose at 1.5, we are getting value of function as 2.5. Similarly, we get very close to 1, that is for 1 point, let's say 0.00001, we are getting value of function as 2.00001, which is again approximately equal to 2. So from this we can able to notice that as x get closer to 1, the value of x square minus 1 upon x minus 1 gets close to 2. So we are facing very interesting situation here, where when x is equals to 1, we don't have any answer to this because it's indeterminate form, that is 0 by 0. So that's why we don't know any answer, but we still can see that it's going to be 2. Okay, so we want to answer 2, but we can't. So instead, mathematicians say what is happening here by using the word limit. They say the limit of x square minus 1 upon x minus 1 as x approaches 1 is 2, and they write it is as limit of x tending towards 1, x square minus 1 upon x minus 1 is equals to 2. So basically, limit is a special way of saying ignoring what happens when we get there, but as we get closer and closer, the answer we get closer and closer to 2. So this is what we uh, this is how we use limit concept. So now let us look this scenario by through graph. So graph of this looks like this. We can observe in the graph that at point x is equals to 1, we have hole in the graph. The hole indicates function doesn't give any output at this point. So but if we analyze the behavior of this function in its neighborhood of 1, we can say that as we approach 1, the limit is 2. So the next possible question may arise that does the limit of function always exist? So answer to this question is big no. Limit of function does not exist always. Okay, if you have cases like this, where if you are approaching from left hand side and you are approaching from right hand side, in the both cases you are approaching towards same value, then only you can predict that the limit of this function at this particular point will be this. But if you have cases like this, where if you are approaching from left hand side, you are getting value 3.8, and similarly if you are approaching from right hand side, you are getting value 1.3. In such cases where you are getting different values if you approach from left hand and right hand side, so in such cases you can't predict the behavior of function at a. So we will say limit does not exist, where we are going to denote the left hand limit. We call this as left hand limit, means the value of limit as we approach the function from its left hand side. And similarly this symbol indicates we are approaching from right hand side. Notice that for approaching towards a from left hand side, we are using a minus symbol. It's just a symbol, and where minus sign indicates that you are approaching from left hand side. Similarly here the plus sign indicates you are approaching towards a from right hand side of a. So in conclusion we can say that limit exists if left hand limit is equals to right hand limit, and limit does not exist if left hand limit is not equal to right hand limit. And mathematically we are going to say this, like define the limit like this. Suppose you have function fx and the value of function attends the variable x approach to a, and it's called a limit. Here a is pre-assigned value, it may be anything, but it should be pre-assigned, that is it's not a variable. So limit of x tending towards a, fx is equals to L. So in this definition, L will be called as limit of function as x approaches a. And we can define the limit like this if we have this if this condition holds. And what this condition says, this is a left hand limit as we discussed earlier, this is a right hand limit. This condition say that the limit of function at point are the common values of left hand and right hand limit. Means left hand right hand limit both should give you common value. In that case only you are able to define limit like this. Suppose you get your left hand limit as L and you are getting your right hand limit as M and N are different numbers. So in such cases limit does not exist, so no question for how to define limits. But if you are getting same value, then in that case the same common value L will be called as limit of function at that point. Okay, so this was all about limits, and now let us conclude this topic with one example. Suppose we want to determine the limit of this function x square minus 4 upon x minus 2 as x approaches 2. So if we directly substitute the value of point inside the function, we get 4 minus 4 upon 2 minus 2, that is 0 by 0, which is indeterminate form as we discussed earlier. That means function is not defined at the point x is equals to 2. Now if we still want to find the behavior of function at point x is equals to 2, for this we have to use some tricks here. Tricks is basically rearrangement of this function, and somehow we are going to eliminate this term x minus 2, and we can easily find the approaching value of this function. How we are going to do the arrangement? For adjustment purpose we are going to use this identity that we have studied in our 8th 9th class. A square minus b square is equals to a plus b into a minus b. We are going to use this identity here. X square minus 4 can be written as 2 square, so we have x square minus 2 square in numerator. So by using this identity we are able to write it as x plus 2 into x minus 2, and in the denominator we have x minus 2. Now by the concept of limit we have noticed that limit of x tends to 2 means x is approaching towards 2 from both sides, left and right hand side, but it's very close to 2 but not exactly equal to 2, and as it is not exactly equal to 2, x minus 2 will become non-zero quantity, and as x minus 2 is non-zero quantity we are able to cancel it. So we are cancelling x minus 2 from numerator and denominator from both, and now we have limit of x tending to 2 x plus 2, and now we substitute value of point inside the function, we get 2 plus 2 is equals to 4. So therefore limit of x tends to 2 x square minus 4 upon x minus 2 will be equal to 4. So let's see in the options. Here we can see option C is the correct one. And that's it from my side. Thank you for your attention.